Standard 1.7. Fill in angle and coordinate values in the unit circle and use the unit circle to evaluate sine and cosine of special angles in degrees and radians. All right, so basically the standard is about finding sine and cosine of given angles. And we're going to use our unit circle to do this. Now, when you're thinking about sine and cosine, keep in mind that the sine of theta is y over r, and the cosine of theta is x over r. And what's so special about the unit circle is that the radius is 1. And when the radius is 1, then sine of theta is y over 1, or just the y coordinate. And the cosine of theta is x over 1, or just the x coordinate. So the unit circle is very handy because we can use the x coordinate to determine the cosine of an angle and the y coordinate to determine the sine of an angle. For example, let's take 225 degrees and find the sine of that angle. Sine of 225 degrees. And so what we need to do is find that angle on the unit circle, and then because we're finding sine, it's just the y coordinate. Okay? So here's our unit circle. We find 225 degrees, and the y coordinate here by the hand is negative root 2 over 2. And so because we're finding sine, we're going to grab that y coordinate as our value. So the sine of 225 degrees is the y coordinate of that angle, which is negative root 2 over 2. And that's it. So let's do another one. Let's find the cosine of 5 pi over 6. Keep in mind that the input here are angle measures, and they can be in degrees or in radians, but the output is a ratio, and it's just the x coordinate or the y coordinate. So we're going to find 5 pi over 6, and since we're finding the cosine, now we're finding the x coordinate of 5 pi over 6. So let's find 5 pi over 6, it's by the hand here. And the x coordinate is negative root 3 over 2. And so the cosine of that angle is negative root 3 over 2. And that's it. Let's do another one. Let's find the sine of negative 2 pi over 3. Now we have to come to our unit circle and find negative 2 pi over 3. But if you notice, our angles are all being measured in positive radian values. So where the heck is negative 2 pi over 3? You might recognize it as the same thing as positive 4 pi over 3 over here. But if you don't recognize it as that, that's where our lesson on coterminal angles comes in handy. So negative 2 pi over 3 has the same terminal ray as any angle coterminal with it. And to find coterminal angles, we can add or subtract 2 pi. And you can use your calculator if you want. That was the previous lesson. Or you can get a common denominator, which I'm doing here, and it's 4 pi over 3. And since negative 2 pi over 3 and 4 pi over 3 have the same terminal ray, it's going to have the same points on that terminal ray on the unit circle. So instead of finding the sine of negative 2 pi over 3, we can find the sine of positive 4 pi over 3. And let's go to a unit circle. Here's positive 4 pi over 3. Since we're finding sine, it's the y coordinate. It's negative root 3 over 2. And so that value is going to be negative root 3 over 2. Let's do another example. Let's find the cosine of 422. degrees. Now, if we look on our unit circle, we don't see the 420-degree angle. You might be able to recognize where it's going to be on our unit circle, but if you're not sure, find a coterminal angle. Now, all the angles in degrees here lie between 0 and 360. So how are we going to get between 0 and 360 an angle that has the same coterminal ray as 420 degrees? Well, we can subtract a full rotation. That's how we find coterminal angles, and that's 60 degrees. And so cosine of 420 degrees is the same as the cosine of 60 degrees, and that's because they have the same terminal ray. Let's find 60 degrees. Cosine is the x-coordinate, and that is 1/2. And so the cosine of 420 degrees, which is the same as the cosine of 60 degrees, is equal to 1/2. One more example, or maybe two more. Let's find the sine of pi. And so let's go to our unit circle. Sine's the y-coordinate. Pi is out here. Ooh, in this case, the y-coordinate is 0. And so the sine of pi ends up being 0. And let's find the cosine of -90 degrees. -90 degrees is not on our graph, but if we add a full rotation, we have the same terminal ray. That's 270 degrees. So finding the cosine of -90 is the same as finding the cosine of positive 270 degrees. Cosine is determined by the x-coordinate. Here's 270. The x-coordinate down here is 0. And so the cosine of -90 degrees is 0. If we go back to our unit circle, some of you may be concerned as to how you're going to memorize these values. Keep in mind that the only values you really need to memorize are the 30 here, the 45, and the 60. And the 30 and the 60 are actually the same values. It's just the x and y coordinates are switched, and that's because the 60-90 triangle is in a different position here. Once you have these three coordinates memorized, just reflect them to find your coordinates in the other quadrant. So for example, for the 30 degrees along this blue radius here, you have root 3 over 2 comma 1/2, but when you flip it across the y-axis, your x-coordinate becomes negative. Down here, both coordinates become negative. And in the fourth quadrant, the y-coordinate is negative and the x is positive. So the values are really the same. It's just the sign, S-I-G-N, sign, that changes. And the quadrantals here at 0 and 90 and 180 and 270 and 360, well, those are 1 unit away from the origin. And so the coordinates are going to be 0, 1 or 1, 0 or something similar on the negative side. So this is standard 1.7, finding the sines and cosines of angles using your unit circle.